have this molecule over here, and I want to name it. First thing we need to do is find the longest parent chain. And the way we're going to do that is we're just going to count the longest continuous number of carbons. If I go across this way, it's going to be 1, 2, 3, 4, 5, 6, 7. If I go this way, 1, 2, 3, 4, 5, 6, 7, 8. If I go this way, 1, 2, 3, 4, 5, and go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this would work. This would work. So, okay, good. So let's get our longest one, which is this one right here. Doesn't matter if you take this one or this one. So 1, 2, 3, 4, 5, 6, 7, 8. So our parent is an octane because we've got 8 carbons. What are we supposed to do next? Circle all the substituents. So we have this 2 carbon substituents hooked up here, this 3 carbon substituent hooked up here, and these 2 1 carbon substituents. Okay, we're going to number it so that the substituents get the lowest possible numbers, and so that your first substituent hits at a very low number. If you number it this way, your first substituents hit at carbon number 2. If you number it this way, your first substituent would hit at carbon number 4. So obviously you got to go left to right. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, next step, we identify these substituents. What are these things? We recognize that this is a 2 carbon one, so it's an ethyl. We recognize that this is a 3 carbon, but notice it's hooked up from the middle carbon, so it's an isopropyl, not a propyl. And then this one's a methyl and this one's a methyl. So we have to tell everybody where the substituents are, what carbons, and we have to alphabetize. Remember, E comes before I, which comes before M. Since both methyls are on carbon number 2, you have to mention the number 2 twice. If you had a methyl on carbon 2 and on carbon 3, you would say 2, 3 dimethyl. But since they're both on 2, I know it sounds weird, but you have to do 2, 2. Okay, so let's do this. We're putting the ethyl first. The ethyl is on 5, the isopropyl is on 4, and the 2 methyls are on 2. So we're going to say 5-ethyl dash 4 dash isopropyl dash 2, 2 dash dimethyl. Remember, the di is not alphabetized, the methyl is. And I'm going to continue it over here, all one word, octane. Okay? That's how you name these types of things. All right? We can leave this now, and we can get into cyclo alkanes, which are cyclical structures. This is when you take an alkane and you get rid of 2 hydrogens and you make the end carbons loop around and connect with each other. So think of this. Think of a butane is 4 carbons, and butane has 10 hydrogens. All right, so I'm going to take this butane and turn it into a square. So I'm going to get rid of this hydrogen and this hydrogen. Have these 2 carbons connect to each other. And that's what it's going to look like. So notice when you turn an alkane into a cycloalkane, this is a cycloalkane, you got rid of 2 hydrogens. So the general formula would be CnH2n and not plus 2. Remember, the alkane was CnH2n plus 2. Cycloalkanes are CnH2n. We tend to use a lot of line drawings with cyclical structures. So if you have 4 carbons, it would look like a square. If you have 3 carbons, it's a triangle. If you have 6 carbons, it looks like a hexagon. So 4 carbons, this is called cyclobutane because but means 4 carbons. This would be cyclopropane. And guess what this guy would be? Because it's 6. 6 is hex, so this is cyclohexane. Okay? Good. All right, so what if we have a cyclical structure with substituents? So let's say I've got this, and I draw a line out. What do you think that line means? That's really a methyl group. So if this was expanded, it would look like this. I'll fill in the hydrogens. So sometimes you'll see it just written as a line like that. This is the same as this. All right, so I need to tell someone that I have a methyl group on this cyclobutane. How do I say that? Well, remember, longest parent chain is the cyclobutane. So that methyl group is attached. What carbon is it attached to? Remember how you want the substituent to be the lowest possible number. Well, with a ring, you get to number it any way you want to. And so it makes sense to give the substituent carbon number 1. So this is immediately carbon 1. And because if you have just one substituent, you have one substituent, it's automatically at carbon number 1. Because it wouldn't make sense for you to number this 1 and then say, oh, my substituent is at carbon 2. The whole point of all of this is that you want your substituents to be at the lowest possible number. So because it's automatically carbon 1, you don't even have to say 1, you just say methyl cyclobutane. Because everybody knows that there's a methyl group and it's on the cyclobutane and it's an automatic carbon number 1. All right, let's do another one. What if I have a methyl here and a methyl here? Now I have to tell everybody where they are because it could be, they could both be coming off of the same one, or they could be here and here. So now we need to number it. It doesn't matter which one gets the 1, but one of them has to get the 1. So let's say I give this one a 1. So this would be 2, and this would be 3, and this would be 4. So what would the name be? The name for this one would have to be 1, actually let me erase this name. It would be 1, 3 dash dimethyl cyclobutane. Don't forget the cyclo and don't forget the di because you have 2 of them, so you've got to tell everybody that you have 2. Okay, when you have just one substituent with a cycloalkane, you do not have to put any numbers down. The minute you have more than one, you got to tell me where they are, okay? Because it could have been 1,1-dimethyl cyclobutane or 1,2 dimethyl cyclobutane. You would never have a 2,2 dimethyl cyclobutane because you should call it a 1, okay? We're going to talk about cis-trans isomers next in the next video, okay?